China's semiconductor industry has made significant strides in recent years, with the announcement of China's first 3nm smartphone system on chip. This achievement is particularly noteworthy given the ongoing global semiconductor competition. Rumors have circulated about Chinese tech giants' ability to manufacture advanced node chips without extreme ultraviolet EUV lithography machines from ASML. This development places Japan among an elite group of global technology companies capable of developing 3nm chips. SHOM's journey in chip development spans back to 2017 when the company introduced its first custom chipset, the Surge S1. The Surge S1, built on a 28nm node, featured a 64-bit octa-core processor with a big. LITTLE architecture and reached maximum clock speeds of 2.2 GHz. This initial foray into chip development laid the foundation for SHOM's ambitious semiconductor roadmap. SHOM expanded its chip development portfolio significantly, creating the Surge C1 for image processing, Surge G1 for power management, and Surge T1 for system improvements. These specialized chips demonstrated EXIM's strategic approach to in-house semiconductor development, focusing on specific functionalities rather than immediately pursuing general-purpose processes. The path to the current 3nm breakthrough hasn't been straightforward, as Wang Tang, Deputy General Manager of SHOM's China Market Department and General Manager of Redmi brand, recently explained that the adoption of 3nm process technology significantly impacts manufacturing costs. This cost increase has direct implications for the pricing of EXIM's flagship phones, reflecting the substantial investment required for cutting-edge semiconductor development. Technical specifications of the new 3nm chip remain partially undisclosed, creating significant industry speculation. The successful tape-out confirms the completion of the design phase, but crucial details about the CPU cluster GPU implementation and whether the chip will utilize ARM designs or a custom architecture remain unknown. Samsung Microchips Corporation, SMCC, emerges as the likely manufacturing partner due to several key factors, including its position outside the US Entity List, which enables access to TSMC's advanced manufacturing services. This development coincides with SHOM's broader product strategy at the 2024 Snapdragon Summit in Hawaii, where it announced its 15 series would be the first to feature the Snapdragon 8 Elite chip. This diverse application of proprietary chip technology indicates EXIM's broader ambitions in the semiconductor space in the context of international technology relations. However, experts emphasize the importance of approaching these claims with appropriate scrutiny. The integration of the 3nm chip technology with Xiaomi's software ecosystem is a significant aspect of the development. The upcoming devices featuring the 3nm chip will run HyperOS 2.0, Qualcomm's newest operating system, which promises enhanced security features, improved animations, and advanced multitasking capabilities. This advanced hardware capabilities of the new chip have market implications that extend beyond Xiaomi's immediate product line. The ability to produce 3nm chips could potentially enable other Chinese companies to access this technology, though the complexities of international trade regulations and intellectual property considerations remain significant factors. Qualcomm's current strong position in the Chinese market, with over 50% year-on-year revenue growth from mainland smartphone makers, adds another dimension to this evolving landscape. Memory costs present an additional factor in the broader market impact, as memory prices have reached peak levels after a year of continuous increases. This combination of advanced chip production costs and rising component prices suggests significant implications for consumer device pricing across the industry. The verification status of this development remains a point of discussion within the industry, while Tang Jiangou's announcement carries the weight of his official position. SHOM's measured silence on the matter reflects the sensitive nature of advanced semiconductor development in the current geopolitical climate. Industry watchers await potential confirmation from Xiaomi founder Junle, particularly given the technical complexity involved in 3nm chip production. The technical advancement from 28nm to 3nm represents a remarkable leap in semiconductor manufacturing, placing SHOM's capabilities near those of industry leaders like TSMC and Samsung. Advanced node production is particularly noteworthy considering China's limited access to extreme ultraviolet EUV lithography equipment from ASML. Performance expectations for the new chip suggest capabilities comparable to current flagship processors. The manufacturing process involves several critical stages beyond the initial tape-out small batch production for testing yield rate optimization and potential design modifications. Industry experts emphasize that successful high-volume production at 3 nanometers requires extremely precise process control and sophisticated quality management systems. Looking ahead to 2025, Xiaomi 15's Pro is positioned to showcase this technological achievement, integrating advanced AI features, enhanced battery management systems, and improved processing capabilities, all optimized through the combination of the 3-nanometer chip and HyperOS 2.0 operating system. This development has particular significance for Xiaomi's artificial intelligence capabilities, as advanced node processors are crucial for implementing sophisticated AI features in mobile devices. The 7-year gap between major semiconductor releases suggests a methodical approach to capability development rather than rushing to market with intermediate solutions. The role of domestic semiconductor policies becomes increasingly relevant, with Beijing's investment in the sector reportedly reaching tens of billions of dollars. However, the interaction between domestic capability development and international technology access remains complex, particularly given ongoing export control regulations. Market analysts note potential implications for component suppliers as Xiaomi develops more in-house capabilities. Nearlink, also known as SparkLink, is set to redefine wireless technology with 6 times faster speeds, 60% less power, 10 times more device connections, and ultra-low latency across a 600 m range. Nearlink offers much lower power consumption, faster speed, lower latency, more stable connectivity, wider coverage, and more powerful networking. It is definitely way ahead of others. The Nearlink Alliance, led by Huawei, was established on September 22, 2020 with the goal of formulating a new standard for short-range wireless communication. As of September 2023, the alliance has grown to include more than 300 enterprises and institutions, including automotive manufacturers, chip and module manufacturers, application developers, ICT companies, and research institutions. The development of Nearlink has been rapid and focused, with the finalization of the Nearlink 1.0 standards in November 2022. The technological advancements of Nearlink are truly impressive compared to traditional wireless connections. Huawei's Nearlink boasts several significant advantages, such as 60% lower power consumption, 6 times higher speed, 130th delay, and support for 10 times the number of network connections. This doubling of range opens up new possibilities for wireless connectivity in larger spaces and outdoor environments. Nearlink's extended transmission range is particularly noteworthy, as it can achieve a range of up to 600 m, opening up new possibilities for wireless connectivity in larger spaces and outdoor environments. The transmission rate of Nearlink is equally impressive, with speeds of up to 900 megabits per second, far outpacing Bluetooth's 50 megabits per second and even surpassing Wi-Fi 6's 600 megabits per second. Nearlink employs several advanced technologies, including GFS modulation, PSK modulation, ATIS forward error correction FEC based on polar codes, and cyclic prefix orthogonal frequency division multiplexing cyclic prefix OFDM waveform. These technologies address latency issues in various applications, reducing transmission latency to approximately 20 microseconds. Nearlink technology, NLT, is a technology that consists of 3 main layers: the physical layer, data link layer, and network layer. The physical layer handles the transmission and reception of high-frequency signals, while the data link layer handles packaging, unpacking, validation, and error correction. The network layer ensures data transmission to its intended destination. Huawei has developed 2 Nearlink modules, the H383U and H383s, which support 802.11 BG/NAX Bluetooth Low Energy Nearlink and USB communication interfaces. The H383U module measures 12.00 mm by 12.00 mm by 2.2 mm and supports 802.11 BG/NAX Bluetooth Low Energy Nearlink and USB communication interfaces. The H383's module is slightly larger at 12.20 mm by 13.0 mm by 1.8 mm and uses an SDI communication interface instead of USB. Both modules support the coexistence of Wi-Fi and BLLE, allowing for flexible integration into various devices. NRT technology has applications in consumer electronics, smart homes, electric vehicles, industrial smart manufacturing, and smart wearables. It can create lower latency, lower power consumption, wider coverage, and safer connections. For users in the automotive industry, NLT enables high-speed, high-capacity, low-latency, and high-precision connections and interactions between cars and mobile phones. In the smart industry, NLT allows industrial robots, sensors, and controllers to achieve high-speed, high-capacity, low-latency, and high-reliability connections and collaborations. In the gaming industry, NLT's ultra-low latency can significantly enhance the gaming experience, particularly for multiplayer and VR/AR gaming scenarios. The technology's high bandwidth and low latency are ideal for virtual and augmented reality applications, potentially enhancing immersion and reducing motion sickness for wireless audio applications. NRT also revolutionizes the performance of devices such as headphones and speakers, allowing users to enjoy high-quality audio streaming without interruption, and with the extended range they can move around their environment without worrying about signal loss. However, NLT faces several challenges for widespread adoption. First, it requires devices to be equipped with NLT chips, which could slow adoption rates, particularly in markets where consumers are accustomed to long device life cycles. Second, while NLT has been approved as an international industry standard, it will take time for it to be widely adopted across different industries and regions. The success of any new technology standard depends not just on its technical merits but also on its ability to build a robust ecosystem of compatible devices and applications. Despite these challenges, the significant advantages of NLT, such as superior performance in terms of speed, latency, power consumption, and connection capacity, make it an attractive option for a wide range of applications. As more devices incorporate NLT technology and the ecosystem of compatible applications grows, we may see a shift away from Bluetooth and Wi-Fi towards this new standard. Apple has opened its largest applied research laboratory outside the United States in Shenzhen, China, marking a significant expansion of its research and development capabilities. The facility, strategically located in the Heta Shenzhen Hong Kong Tech Cooperation Zone, is set to enhance Apple's testing and research capabilities for major products such as the iPhone, iPad, and the Vision Pro mixed reality headset. The lab also aims to strengthen Apple's collaboration with local suppliers, a crucial aspect of its operations in China. Apple announced its plans to build the new Shenzhen lab in March 2024, setting the stage for a significant expansion of its research and development capabilities in China. The primary purpose of this facility is to enhance Apple's testing and research capabilities for its major products, including the iPhone, iPad, and the Vision Pro mixed reality headset. The lab is expected to employ over 1,000 domestic and international talents, making it the company's most extensive lab outside the United States. The expansion of research capabilities comes at a critical juncture for Apple in the Chinese market, which represents Apple's largest geographical market after the Americas and Europe. However, the company faces unprecedented challenges in maintaining its market position against increasingly competitive domestic players. Recent market data paints a concerning picture for Apple's performance in China, with Huawei outselling Apple in mainland China for the first time in almost 4 years in August 2024. Apple's market position in China has weakened considerably during the second quarter of 2024, falling out of the top 5 smartphone vendor rankings in the country. Research firm IDC reported that Apple's market share in China dropped below 14%, a significant decline from its previous dominant position. This shift in rankings reflects the changing landscape of the Chinese smartphone market and the increasing competitiveness of local brands. Apple's combined sales in mainland China, Hong Kong, and Taiwan fell by 6.5% year-on-year in the June quarter, amounting to $14.7 billion. This decline in one of Apple's most crucial markets has raised concerns about the company's long-term growth prospects in the region and its ability to compete effectively against domestic rivals. In conclusion, Apple's decision to invest heavily in research and development in China demonstrates its commitment to regaining lost ground and overcoming competition from domestic players like Huawei.